Alright, so we've already talked about the unit circle, and we've talked about some of the pi over 6 and pi over 4 units, or when we rotate by pi over 6 or pi over 4 radians. And just before we get into then what would be the x and the y coordinates at any of those points, I wanted to complete this page with you about special triangles so that you can see exactly where the numbers come from. Just before I get started, I just want to just do a quick reminder of how fractions and square roots work. So for example, if I had a value of a half and then I wanted to do a square root of the 1/2, this would be the same thing as the square root of 1 divided by the square root of 2. So you can see how if you have a square root of an entire fraction, it's the same thing as the square root of each numerator and denominator. The square root of 1 is 1. And so we could stop here. We could say 1 over the square root of 2. Sometimes in math we don't like to have a radical, a square root sign in the denominator, and we would want to change that. So we would multiply by root 2 over 2. So you see what happens is in the denominator you get root 2 times root 2. So now I would get root 2 over 2 as my answer. You're going to see, depending on the resource that you use, you'll see this as an answer and you'll see this as an answer as well. I tend to use this one, and you're going to see why, so that there's a pattern. I'll do one more example. If we had a fraction of 3/4 and then we do a square root of that, we would get the square root of 3 divided by the square root of 4, so that would turn into the square root of 3 over 2. Okay, so we're going to see these values showing up. So the first special triangle we're going to talk about is the 45-degree triangle. So if we start off with a right triangle where each of these two sides are the same, that means that these base angles are each going to be the same as well, and those will each be 45 degrees, right? That's 45 degrees. I'll see if I can find a place to write 45 degrees. Okay, so what we're going to do is we're going to say, well, if this hypotenuse has a value of 1, then what are these other sides? Okay, and normally we would write like c squared is equal to a squared plus b squared for finding sides of a right triangle. Since these two, a and b, are both the same, I'll just use an x here. So my c squared, that's the hypotenuse, that's 1. So I'd say 1 squared, which is still 1, is going to be equal to x squared plus x squared. So I'll say 1 is equal to 2x squared. And so again, what I'm doing is I'm figuring out what are these two sides here, the x and the x on the 45-degree triangle. I'll divide both sides by 2, so I get 1/2 is equal to x squared, and then you see where we're going on this. It's going to turn into this, right? I'm going to do the square root of both sides. In fact, I'll switch the sides too, so I have x on the left. So I get the square root of 1 over 2, and so that's equal to 1 over root 2, or root 2 over 2. Okay. Now, if you were to put this in as a decimal, if you're going to do it in your calculator, the square root of 2 is about 1.414 divided by 2. We end up getting 0.707. So this would be the exact value. And this is a decimal rounded off to how many digits. So unless they say, please give your answer as a decimal and round to so many digits, this is a better answer because it's exact. It's not rounded at all. So that's the one I would prefer. Okay, so that's the first special triangle. The second, you know what, let me just show you like where you would see that then. I'll switch to red here. So if we were to make an angle of 45 degrees, so an angle of 45 degrees, kind of like that, right? 45 degrees there. So this hypotenuse, we said, was 1. So here's the hypotenuse of 1. And then the sides would be this and this, all right? These would be the two sides. Now, my two sides don't look the same. I didn't draw my angle very well. So the length of this side is this root 2 over 2. And the length of that side is root 2 over 2. And my writing is very messy on this pad. Okay, so let's try the other one, the 30, 60, 90 triangle. So first of all, this is an equilateral triangle, so each of the three sides are the same, and so each of the three angles are the same. So each of these are going to be 60 degrees. 60, 60, 60. So let's say we start with one of those, and then the first thing we do is draw a line straight down the middle that would bisect this side and bisect this angle here. So this is our next picture. This is after we've bisected that. Okay, so again, in this particular triangle, we're going to make the hypotenuse equal to 1. This is going to still be 60 degrees. But now, because we've drawn that angle, this one is 30 degrees. Okay, so let's figure out if this was our original side 1, if this side was 1 up here, then this whole side here would have been 1 as well, because it was an equilateral triangle. So just this portion here would be a half. So over on our 60-30 triangle now, I'll label this as a half. And let's figure out what is this other side here. We'll put an x for that. So again, we can use our Pythagorean Theorem. C is our hypotenuse, so we'll say 1 squared is equal to, and then we have our x squared and our half squared. And so just a reminder, we're going to square this whole thing like that. 1 squared is 1 is equal to x squared plus a half squared is a quarter. And then we're going to subtract a quarter from both sides, so we'll get 3 quarters is equal to x squared. And this is like that other example that we warmed up with. So when I do the square root of both sides, and I'll put x first, I get x, and I get the square root of 3 quarters, which is the same thing as the square root of 3 over 2. And so I get my answer. So this was the square root of 3 over 2. Okay, so we're going to be using this a little bit later, and that is the end of our video.